and valleys the Vikindu. Carmel Mount girls, arise, arise, arise.
Hi everyone! In front of you are students of Carmel Mount Girls Secondary School located at Vikindu, and we're here to present an experiment of volumetric analysis. My name is Karen Manza Chihoma.
My name is Karen Depretis. My name is Bibiana. Hi everyone, in front of you is Bibiana Kabea, a Form 4 student from Carmel Mount Girls Secondary School in Vikindu. Our today's discussion is all about titration, and we are going to titrate our solutions today. First of all, before we start, let us know some of the solutions which we are given. We are given an unknown concentration of sodium of azotic acid, which we are about to find, and a known concentration of sodium hydroxide, which contains 0.2 moles. And also we are going to use our POP. How can we start? We cannot start without having an aim of experiment. So let us begin. Today's aim. The aim of today's experiment is to standardize oxalic acid by using sodium hydroxide, which is a known concentration. It contains 0.2 moles. Our given equipment. As I began to say that we are given a known solution of oxalic acid, which we all have our duty to find today, and we have a known solution of sodium hydroxide, which contains 0.2 mole. And we also have phenolphthalein, which is our indicator today. If you are asked, why do we use phenolphthalein or POP as our indicator today? Because the acid which we are given today is a weak acid, and theirs is a strong acid. So we have to titrate it. We cannot use methyl orange because the acid is weak. So we have to use POP because the acid is what? A weak solution. So we are going to begin our titration. First of all, we are given a pipette with a filler. It's filler. You can either fill the pipette by using a pipette filler, which is what I'm holding here, or by sucking, which is mostly used by students in Tanzania. First, we have to remove the air molecules in this filler. We have to compress and pit it here. After that, we are going to take our base, which is sodium hydroxide, and we are going to fill our pipette by using a pipette filler. How can we fill? Insert it in your beaker containing the solution, and hence pinch the upper part. As you can see, it is rising up. There we go. We have already got our volume of base. After that, we are going to insert it in our conical flask. We are going to pinch the lower part here. And our base is going to our conical flask. As you can observe. We already have our base in a pipette. After that, we have to fill our bullet. I will lower my bullet and it will stand at a lower section so as to fill it. I'm going to take my oxalic acid and fill it. centimeter cubic. It should not exceed the upper case. After that, I will return it in upper section for all of us to see. My base, I have to put an indicator. 2 to 3 drops. 1, 2. After that, we are going to the second stage of titration. I will allow a small amount of acid to drop in the pipette containing base so as to make the solution to be standardized. I have to obtain a colorless solution so that to indicate the end point of our chemical reaction. I will begin. You have to shake your mixture. You have to be careful during the mixing. There we go. We have our solution. And after that, we already got our first data. So I'm going to draw our table of results. Before drawing, we were asked the pipette which we used, it is 25 centimeter cubics. So during your reporting, you have to start with the volume of base in centimeter cubics. It is 25 centimeter cubics. After that, table of results. We have to start with pilot as our first experiment, followed by V1, V2, V. Here we write our final reading in centimeter cubic. Initial reading in centimeter cubics. And our total volume in centimeter cubics.
Their final reading is 27.5. It's 27. We have to read the downper meniscus for correct reading and not the upper meniscus. So our final reading is 27. 2700. And the volume is also here will be 27.00. Here I needed to add another volume of acid because approximately the remaining volume will not be suitable for titrating another experiment. So we need to add up to the initial mark of 0. We're going to dispose this and clean our conical flask. The second experiment also, we're going to start the base from the beaker to the pipette. And hence transferring it to the conical flask for further titration. Taking 2 drops of the indicator. We're not supposed to put more than 3 drops or more than 2 drops because sometimes it can lead to errors. We titrate, dropwise acid, we shake, again some little more acid. There, you can see there is a color change. And our final volume is 25.5. While our initial volume was 0.00 and the final reading was 25.50. Hence the volume used was 25.50. Since we're starting to the initial mark, so our initial reading also will be 0.00. After filling the burette, we have to remove this filter, the burette filler, in order to prevent the excess drops from the filter to the burette. As you can see, I'm removing it, and the other procedures follows. As I said, it's not compulsory removing the last drops from the pipette since it will lead to some errors. So we need to be careful when transferring the acid from the pipe, transferring the base from the pipette to the conical flask. Adding 2 drops of indicator. Proceeding with the titration. And our initial final reading will be 25.7. Also, our volume used will be the same, 25.7, while our initial reading for the third experiment will be 0.00. Here is the last experiment, so we're going to titrate. We need to add a little volume of the acid. Adding 2 drops of phenolphthalein indicator. And again we titrate. Sometimes we need to titrate slowly, as when we see the color change is about to be observed, we need to add drops by drops. Because sometimes when you add a very huge amount of acid, you can get incorrect answers. And here we are approaching the end of our titration, since I can see the color changes seen here. And taking our final reading, it's 25.5 centimeter cubic.
The average volume is calculated by taking the sum of the first, the second, and third volumes divided by 3, which the first volume is 26.00 plus, the first volume is this one, 27, plus the second is 26.5, and the third is 26. Divided by 3. From there, the total number of volume is 79.5 centimeter cubic. We should not forget to write the units. Divided by 3, then 26.5 centimeter cubic. This is our average volume. And from here, we're going to write the chemical equation, which is oxalic acid, which is aqueous, reacts with sodium hydroxide, which is also aqueous, to form sodium oxalate, and water. This is in liquid, and this is also aqueous. From our chemical equation, the ratio of number of moles in acid and number of moles in base is 1:2. From our titration formula, which says number of moles of acid divided by number of moles in base is equal to the product of molarity of acid and volume of acid divided by the product of molarity of base and volume of base. Number of moles in acid was 1 and number of moles in base is 2, which is equal to the molarity of acid, which is a known, volume of acid 26.5 divided by molarity of base 0.2 m times volume of base, which is 25 centimeter cubic. From there, on cross multiplication, 0.2 times 25 is 5, which is equal to 26.5 times 2 is 53. MA. Divide by 53 by 53. The molarity of acid obtained will be 0.1 m. From there, we have to find the molar mass of oxalic acid, which is 2C plus 2H plus 4 oxygen. Carbon is 12, so 12 times 2 plus hydrogen, which is 1 times 2 plus 4 times 16. And from there, we get 90 gram per mole. We use the formula of concentration is equals to molarity times molar mass. Molarity obtained was 0.1 times molar mass, which is 90 gram per mole. We all know that molarity, its SI unit is mole per dm cubic. Mole per dm. From here we get 9 gram per dm cubic. And this is the concentration of acid. Thank you. The concentration obtained of acid is 9 gram per decimeter cubic. Thank you for watching.
Hi everyone, my name is Karen Degratis. I'm a student of Form 4 at Carmel Secondary School. Today I'm going to represent the precautions that you need to take when you conduct the experiment of volumetric analysis. First, as you can see, the apparatus that you're going to use, for example, this is a burette. When closing the burette on the aim of this experiment is to standardize oxalic acid by using sodium hydroxide, and given we have a known oxalic acid and sodium hydroxide which has molarity of 0.2. So after titrating, we got the concentration of acid is 9 gram per decimeter cubic. Then from there we are going to see, or we are going to listen, the precautions that we need to take when conducting our experiment. When cramping the burette, you need to be very careful because it is made of glass. So when you use much force on the burette, when cramping, you can break it. And also when filling the burette, you to avoid the bubbles, because the air bubbles, they reduce the volume of the acid, and hence you get wrong answers. Also, when using the pipette, you need to be very careful to avoid air bubbles so as to get accurate answers and the correct volume. And also, when filling the burette, you need to be very careful to avoid putting base in it, because when it reacts with acid, it will form sodium silicate, which when react with glass, it will make it to stack and hence will not function anymore. And also, when using the burette, you should not put base in it, because especially sodium hydroxide, because when you put, it will mix with the glass, forming sodium silicate, which will cause the burette to not function anymore. Thank you for listening.
Hi everybody, my name is Eunice. I'm here to present the application of volumetric analysis as we see at our first experiment. First, volumetric analysis, it is used in medical. How? It can be used to determine the concentration of virus or bacterium in blood sample. Second, volumetric analysis, it is used in industries. How? We can determine amount of acetic acid in vinegar by using volumetric analysis. For example, a table vinegar should have a minimum 5% of acetic acid. Also, volumetric analysis is used in industry. Example, in brine industry, determination of acetic acid present in vinegar. For example, in our table vinegar, it should have minimum 5% of acetic acid. Also, in industries, we can take volumetric analysis to determine amount of acid present in industrial waste for neutralization. Third, industry, it is used in analysis of water. How? We can determine hardness of water by using volumetric analysis by carrying out different titration. Also, volumetric analysis, it is used in agriculture to determine different nutrients or compounds present in the soil. Example, nitrogen, phosphorus, and ammonia. Also, we can use volumetric in other commercial purposes, like determination of iron content in iron ore. Also, volumetric analysis can be used in determination of soil pH for lining process. Thank you for listening. I hope you have understand a lesson. Thank you.
Welcome.
Thank you for watching, and get ready or get prepared to get more videos when we're doing other practicals, example, qualitative analysis and chemical kinetics. Bye!
Carmel Girls, arise. We are marching forward to achieve what we want. We are blessed with the hills and valleys, the Vikindu.